What's going on, y'all? In this lesson, we're going to talk about the number e, which is a mathematical constant very famous in many fields of mathematics. It's approximately equal to 2.71828284594,904, blah, 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 blah. It goes on forever. This will never repeat, and it's an infinite string at the decimal. In other words, there is no fractional version of this. This is what we call an irrational number. The limit definition of this thing is e equals the limit as m goes to infinity of 1 plus 1 over m to the mth power. This function shows up as the natural, this constant shows up as the natural exponent function f of x equals e to the x. In this lesson, we're going to actually see one derivation of this, one location that this shows up in thinking about compound interest. So we're going to walk through that process. But before we actually talk about compound interest, I want to talk about the context in which this actually shows up in many of our lives. To do that, we're going to talk about how banks make money. Interest is something that shows up a lot in savings accounts and credit cards and many financial products. And so we're going to actually talk about a model for financial banking. There are two types of banks in our economy, just to kind of think about different types of products that banks offer. One of them is called a commercial bank. These are the banks that most people use on a daily basis. They take deposits, they provide checking, they have savings accounts, and they also provide loans for businesses, personal loans, car loans, and also mortgage loans, sometimes construction loans also. When you're thinking about this, you can think about like Bank of America or your local credit union or any bank that you would open an account in. Commercial banks are different than investment banks. Investment banks are kind of large financial institutions that allow for corporations to find either bond or stock financing. They offer initial public offerings, they allow debt financing, they facilitate trade, stock trading, etc. So you can think about this like Morgan Stanley, Goldman Sachs, what used to be Lehman Brothers. They've left this earth. We're going to talk about a model for commercial banking today, and we're going to see how interest rates and compounded interest shows up in commercial banks, and thus many of the financial products that you use on a daily basis. To start this, we're going to actually look at a model for how commercial banking works. And we're going to think about how this relates to the concept of interest. So any model is wrong, but some models are useful. What I'm about to describe is a very simplified approach to banking. They're obviously running professional banks takes much more than 5 or 10 minutes to talk about, but this should give the major idea on how banks make money using our savings and how that relates to interest rates. So we're going to actually come up with a model for commercial banking, and we're going to have two types of clients for a commercial bank. So on one side, we're going to have customers called savers, right? So savers deposit money into the bank. And then the other side, we're going to have customers called borrowers, or folks that take out loans from the bank. So the bank sits in between. It's kind of a broker between one type of customers, which we call savers, and another type of customer, which we call borrowers. For the simplification in this particular model, let's assume that we have a bank that serves 10,000 people or 10,000 customers, each of whom puts $110,000 in savings. So when we think about all the customers putting money in the bank, we're going to assume there's 10,000 such savers, and each one has $110,000 to save, right? So one thing that's kind of interesting is when we play the role of savers, we're actually loaning money to the bank. So we put a bunch of money in the bank, and then what the bank does is it will then take our money and loan it out to the borrowers, to a bunch of people who want mortgages, construction loans, car loans. And the whole idea is the bank will charge the borrowers a lot more than it pays us to save our money, right? So once we put our money in the bank offers us an interest rate, what they call some sort of a privilege or an award for putting money there. And then it will loan money out and charge a higher interest rate to the borrowers. And the difference between what it pays us to put our money there and what it charges borrowers to use that money is money that the bank keeps in terms of revenues. So let's actually look at this model. We have savers on one side, borrowers on the other. Remember that we were saying that this bank has 10,000 customers, each of whom has $110,000. So when all those customers put their money in the bank in savings, the bank takes all that money, puts it in a vault, and then thinks about two types of groups of money. One of them is called reserves. We're going to assume that the reserves are 10%. You can think about this like money in the vault and the ability to like pay out customers in case they need it. And then also money to be lent out. So the reason that we don't have to keep 100% of our money in reserves in a banking situation is because if 10,000 people put all their money in the bank, not all those 10,000 people are going to need money on a day-to-day basis. So we save some assets in reserve, and then the other assets, the other money that we have under our management, we can lend out to others to make money on, right? That's the whole idea of the banking system. So remember in this model that we had 10,000 households, each of whom had $110,000. So here's 1, 2, 3, 4 zeros, and then here's 1, 2, 3, 4 zeros. So remember when we have this number of zeros, we just add those on the end. So total of 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. So this would be $1,100,000,000. And then we're going to assume that we put 10% of that in reserve. So 10%, literally, we just, chop off some of this. This is not pure 10%, because 10% would be 1,1. But we're going to assume that we put $100 million in reserve. So we keep that as a way to like pay out the daily expenses, and we make sure we can give people their money back. And then everything else we're going to lend out to others. So we have $100 million in reserves to kind of make sure that our bank is solvent and make sure we can pay our day-to-day stuff back to customers if they want it. And then we have $1 billion to lend out, right? So what the bank is going to do is they're going to charge more money on the loans that they write than the money that they pay to savers to keep their money in the bank. And let's kind of look at that spread. So the whole idea of a savings account is that the bank wants to entice us to put our money in its vault, so to speak. So in order to say like, hey, it's worth your time to keep your money with us, the bank will offer an interest rate. So let's say, right now, I don't know what the current interest rates are. I can tell you that my interest rate at a money market account that I opened in like 2013, I think, has been 1%. I was very lucky to have that. My wife has like one that's like 0.1%. But let's say right now that the bank says, hey, if you put your money in our accounts above a certain threshold, let's say $10,000, we'll pay you 1% back each year. So we're going to introduce a mathematical variable called I sub s. That's the interest rate paid to savers. That's 1% of whatever money you put in. And in decimal form, that's 0.01. So when we look at this model, the whole idea is that every dollar in the savings account, the bank's going to pay 1%. So remember that we had 10,000 households, each of which had $110,000. So at the end of the year, we're going to assume that the bank actually pays only once per year, which is called the number of compounding periods. So we put our money in the bank January 1st. On December 31st, the bank says, hey, you've kept your money with us for an entire year. We're going to pay you 1% back on that. So in terms of the amount of money that the bank still kind of owes us, it's going to be all of the money that we put in originally, plus 1%, which is the fee that we're charging the bank to keep our money there, right? So that's going to be $1,100,000,000 plus 1% means that we just move the decimal place over by 1. Move it over by 2. So 1, 2. And that would be $11 million, right? So if we look at that, the total amount of money that the bank has under management is this. And then this is what they owe customers, our 10,000 customers. And you can think about like how much interest per customer. Well, it's $11 million divided by 10,000 customers. That's $1,100 per customer. That's under the assumption that the bank only accrues interest once a year. So at the end of the year, all of us have, if we haven't touched our money throughout the year in savings and we haven't added anything or detracted anything, we have the original balance that we put in plus the interest that we're owed, and each person ends up with $1,100 extra in their account. Okay, so that's the interest rate that the bank pays on saving, but the bank's not doing this for free. There is a reason why the bank is trying to incentivize us to keep our money in savings, and that has to do with the fact that this exact same time that the bank is managing our money and giving us the ability to put in savings, etc., they are also lending out a portion of that money to borrowers. Car loans, mortgages, business loans, construction loans. So what the bank will do is when they lend out our money to others, they will charge a higher interest rate for that money, right? So when the bank loans money to borrowers, student loans, car loans, mortgages, they'll charge at a higher rate. So we'll say that the interest rate on loans, we're going to assume is 5%. So this is the interest rate on all loans that the bank writes to other customers, which means when we think about how much the bank is going to collect on the $1 billion that they loaned out, remember the whole idea here was the total amount of money under management was $1.1 billion. The bank set aside some reserves, maybe around 10%. In this case, we're being a little bit lax on our math and just saying they set aside $100 million, and then they loan out $1 billion, and they loan out $1 billion at 5% interest. So at the end of the year, the people that wrote the loan still have to pay back the principal, but they owe $50 million in interest because 5% of $1 billion is 50 million, right? So what's interesting about that is the bank has said, hey, savers, we're going to pay you $1,100 per year or 1% on whatever you put in to keep your money with us. Simultaneously, in the back end, the bank has then lent our money out to other people and charged 5%, which is $50 million. So if we asked ourselves the question, well, how is the bank making money? How are these commercial banks making money? There's kind of two answers to this question. One of them is called fees. So every time they write a mortgage and every time they write loans, you have to pay fees to the bank. So that's kind of a way that they charge for their time. But they're also making money on the spread between the amount that it costs to borrow and the amount that it costs to the amount that the bank pays to save, right? Remember, saving was $11 million. They paid $11 million out to the savers, but they collected $50 million out to the borrowers that were using that money. Well, if you look at 50 million minus 11 million, that's $39 million in revenue that the bank makes by taking our money and paying it out to others. And so the point of all this is an introduction to interest rates. This is why interest rates work the way that they do. It's basically a cost to use other people's money now for some future return. And I wanted to highlight kind of an important mathematical concept here. Throughout this entire time, the idea is that we multiply a principal outside of 1 plus the interest rate. And it's always this pattern. We start with some initial amount. So if we're savers, that's the amount that we put into an account at the beginning of a saving period. And then 1 plus the interest rate. 1 means, hey, when I come back to this bank in a year or two, I expect you to pay everything that I put down in savings. And then the interest rate is a little bit extra on top of that. So if you've ever seen on your savings account the little interest post, or if you look at your credit cards and you look at the interest accrued, that's the idea that someone is being charged for the use of money now that has to be paid back in the future. And it's always this principal outside of 1 plus interest rate. Principal outside of 1 plus interest rate. The same thing was true for borrowing, right? Principal, the amount of money loaned out, outside of 1 plus interest rate. So in future videos that we're about to go through for this lesson, we're going to talk about the structure of this interest rate calculation and how that shows up in many contexts when we're talking about financial instruments. And then we're going to develop the concept of natural exponents as a consequence of thinking about how interest rates work. So we'll get to that in just the coming videos. Thanks for your attention all. I'll see you in the next one.